Niacin's emerging role in modulating intracellular cholesterol handling presents a compelling therapeutic opportunity beyond cardiovascular health, particularly in lysosomal storage disorders such as Niemann-Pick disease type C, NPC. In this rare, fatal genetic condition, mutations in the NPC1 gene disrupt the normal transport of unesterified cholesterol out of lysosomes, leading to toxic accumulation of lipids in neurons, hepatocytes, and other cell types. The resulting cellular dysfunction drives progressive neurological deterioration, liver damage, and premature death. While current treatments remain limited and largely supportive, the discovery that niacin upregulates NPC1 expression opens a new line of inquiry into how this well-known nutrient might offer disease-modifying potential. NPC1 is a critical transmembrane protein located on the lysosomal membrane. It functions in concert with NPC2 to transfer free cholesterol out of lysosomes to other cellular destinations, including the endoplasmic reticulum and plasma membrane. When NPC1 function is compromised, as in NPC disease, cholesterol and glycosphingolipids accumulate abnormally, triggering lysosomal stress, oxidative damage, inflammation, and ultimately apoptosis. In the context of this mechanism, niacin's ability to upregulate NPC1 is profoundly relevant. The study from which this insight is drawn demonstrates that niacin stimulates CD38-dependent synthesis of NADP, which triggers calcium release via TRPML1 lysosomal channels. This calcium signaling cascade, in turn, activates liver X receptor alpha LXRA, a transcription factor that drives the expression of NPC1. In experimental models, niacin not only increased NPC1 protein levels in macrophages, but also enhanced the efflux of free cholesterol from lysosomes, confirming functional activation of the cholesterol trafficking machinery. This mechanistic pathway mirrors the very defect seen in NPC disease. While the genetic mutations in NPC1 result in absent or dysfunctional protein, many NPC1 mutations are hypomorphic, meaning they produce partially functional protein that may be responsive to upregulation or stabilization. In such cases, niacin could theoretically enhance the residual function of NPC1, improving cholesterol mobilization and reducing lysosomal storage burden. Even a modest increase in NPC1 activity might slow disease progression or alleviate tissue pathology, particularly in the early or intermediate stages of the disease. Moreover, the anti-inflammatory and anti-apoptotic effects observed with niacin in atherosclerosis models may also apply to NPC pathology. Lysosomal cholesterol buildup in NPC disease is a potent trigger of inflammasome activation and cytokine release, especially IL-1S. Niacin's demonstrated ability to suppress this pathway by restoring cholesterol trafficking and reducing lysosomal stress could help dampen neuroinflammation and preserve neuronal viability, an urgent unmet need in NPC management. While these findings are preclinical and based primarily on macrophage models, the molecular logic is consistent and promising. Niacin engages a pathway that precisely intersects with the pathophysiology of Niemann-Pick type C. Its ability to activate LXRA and upregulate NPC1 without relying on genetic modification suggests that niacin or related analogs could form part of a pharmacological strategy aimed at enhancing endogenous cholesterol clearance in lysosomal storage diseases. Importantly, niacin is already known to cross the blood-brain barrier in pharmacological doses, raising the possibility of central nervous system benefits. In neurological forms of NPC, where brain cholesterol export is critically impaired, the ability to influence lysosomal function in neurons or glial cells could be transformative. Furthermore, niacin's safety profile, affordability, and oral availability make it an attractive candidate for repurposing, especially in combination with existing agents like miglustat or 2-hydroxypropyl cyclodextrin. In conclusion, the finding that niacin upregulates NPC1 presents an exciting translational possibility. While originally studied in the context of atherosclerosis, this effect may have far-reaching implications for lysosomal storage diseases characterized by cholesterol trafficking defects. Future research should investigate niacin's ability to modulate NPC1 function in NPC disease models, with the long-term goal of developing adjunctive or standalone therapies that address the root biochemical defect of this devastating disorder.